Exercise 15.2, transformations of graphs using y equals k times your function of x. And this is also k times your function of x, but k times the function of x with a sideways shift as well. Okay? These are called vertical dilations. So it's being stretched vertically. But it doesn't have to be just stretched. It could be compressed. Because you can have, so we're just going to look at that now. So for the curve y equals function of x, y equals k times function of x dilates the curve vertically along the y-axis by a scale factor of k. So for example, if k is 2, like last year in year 11, we were sketching things like x squared, 2x squared, 4x squared. What happens with 2x squared and 4x squared? Does it get steeper? Yeah, so it gets steeper. So if k is greater than 1, we say it's stretched or expanded, but you could say, I suppose it gets steeper. Wait, stretched, for example. If I look at, I'll come back up there in a minute. If I've got y equals x squared and I've got y equals 2x squared, right? So 2x squared, what would be some points on it? Go. 2x squared. Give me. When x is 1. When x is 0, y is 0. When x is 1, y is 2. And when x is 2, y is 8 for the new one. 2, 8, 1, 2. So this is y equals 2x squared. Okay? So what is y equals 2x squared? This is, so y equals x squared has been stretched by a factor of 2 from the x-axis. Okay? So do you want me to put where the original one was? It was like this. The original one would have looked like that. I've got it dotted. So y equals x squared is dotted. Y equals 2x squared is in pink. Is that okay? So we will say that it has been stretched by a factor of 2 from the x-axis. So what do we mean by that? Before, we had the point 1, 1, but it's been stretched to double that from the x-axis. That's how your textbook describes it, okay? This point was 2, 4. It's now 2, 8, okay? So the y value so it's been stretched from the x-axis. From there upwards, it's been stretched, okay? All right, so it's been stretched by a factor of 2 from the x-axis. So it's gone from 1, 1 to 1, 2. It's gone from 2, 4 to 2, 8. Actually, I know my diagram is really bad, the dotted one, okay? But I'm just trying to show that this is steeper than that. What about, so we've got, if k is greater than 1, the graph is stretched or expanded from the x-axis. Let's just write that. So if k is greater than 1, the graph is stretched or expanded from the x-axis. I would just use the word stretched. All right. Now, if k lies between 0 and 1, in other words, if it's a fraction, the graph is shrunk or compressed. Let's see. We'll do a sketch. Okay. Ready? Equals x squared in red. Y equals 3x squared has been stretched from the direction of the x-axis, and y equals a quarter x squared has been compressed from the direction of the x-axis. So the one that you've got on your sheet is a half x squared. It's been made wider. So it's, you know how, well, if the blue one is stretched
along the y-axis?
They use the wording from the x-axis. Yes, from the bottom up. Yes. So this one, so y equals 2x squared. So x squared is in black. Y equals 2x squared is in pink. It's been stretched away from the x-axis, right? This one here, y equals a half x squared. So for this graph, y equals half x squared. The graph y equals x squared has been compressed by a factor of 2 from the x-axis. All right, so I'm going to put in y equals x squared first. 1, 1 and 2, 4. So this is, wait a sec, this is the original y equals x squared. In pink, y equals a half x squared. When x is 1, y is a half. When x is 2, y is 2. So this is the graph you want. A half x squared looks like this. Now you can also see a half x squared written as x squared on 2. So it's been compressed by a factor of 2. Does this sort of make sense? So instead of 2, 4, it's now 2, 2. So the y value, notice the y values get changed when you've got a constant out the front. It's the y values that get changed. So I had 2, 4 originally. I've now got 2, 2 for the same corresponding x value. Yes, no? So it has been compressed by a factor of 2 from the x-axis. Oh dear. Okay, the next one. Y equals. Or it's been made wider. You can write that too. It's widened. Okay. Y equals a half x squared is wider than y equals x squared. But they want you to talk about stretching, dilating, compressing. All right? All right, what about the next one? Y equals a half x minus 1 squared. That actually could also be written as y equals x minus 1 squared over 2. So you could see it written like that as well. Okay, so what is this? What's happened to this curve? Well, actually, what happened to y equals x squared? So this is y equals x squared, shifted, compressed, and then shifted, or it doesn't matter. Shifted 1 unit to the right, because of the minus 1. It's the opposite. You look at the brackets and you say what makes x minus 1 equal to 0, and it's x equals 1. All right, so instead of here being, so we're shifting the pink one 1 unit to the right. This is the pink one here, shifted 1 unit to the right. All right, so this is y equals x squared on 2, or a half x squared, shifted 1 unit to the right. Or, is that okay? All right, so just shift your pink one 1 unit to the right. So instead of 0, 0, what have I got? The vertex is at 1, 0. All right, this other point was 1, a half. So you're going to have 2, a half. And the other point was 2, 2. You're going to have what? So instead of 2, 2, what are you going to have? No, 3, 1. 1, 2, 3. No, you're not. Instead of 2, 2, what are you going to have?
3, 2.
3, 2. 1, 2, 3, 2. Look, it's going to look like that. You know it's going to look like that. All right, it's wider. It's wider and it's moved 1 unit to the right. So you're going to have to label some point, schools. So I've got 1, 0 as my vertex. This will be the point 3, 2, because it's this one moved across 1 unit. What's the y-intercept going to be? Well, that's when x is 0. What do you get? When x is 0, what do you get? You can't see it. Well, you can't really see it there. Anyone? Substitute. When x is 0, what do you get? Yeah, a half. So this is the point 0, a half. Okay? So this is wider than the x squared graph, and it's shifted 1 unit to the right. Sorry, girls, these are all a bit everywhere. Equals e to the x is there. So when x is 1, y is 0. When x is 0, oh God. When x is 0, y is 1, because e to the 0 is 1. And when x is 1, y is e. So that's 2 points. All right, y equals 3e to the x. What are you going to do? Just explain what would happen to that graph. It would be stretched by a factor of 3 from the x-axis. Okay? Stretched by a factor of 3 from the x-axis. Then you can do a third e to the x, which is e to the x over 3. And then we're going to do the same graph as the top one with a sideways shift. Okay, so this one we're thinking stretched vertically or stretched by a factor of 3 from the x-axis. So we're going to write that all. Okay, so what's the first point? But be very, very careful. When x is 0, what do you get? Yeah, don't put 1. When x is 0, you get 3 times 1 is 3. When x is 1, you get 3e, which is approximately 3 times, it's a bit less than 9. 8 point something, more than likely. Or you can work out an approximation on your calc, whatever. So we've got the point 0, 3, and we've got 1 up there, 3e. So please, 1, 3e, and down there. Okay, so this has been, so y equals e to the x has been stretched by a factor of 3 from the x-axis. Or you could say it's been stretched vertically. So it's been stretched by a factor of 3 from the x-axis. All right, stretched from there upwards. Got it? The next one, y equals e to the x over 3, which happens to be a third times e to the x, has been, what would you say? Instead of stretched from the x-axis, it's been compressed. All right, so put some new points. This was the point 3, so make sure you put that, or 0, 3. It's the intercept 3, or it's 0, 3. All good? Keep going. Do it. Do this one. Okay? If you want, when x is 2, you get e squared on 3, if you want. Okay? I'm thinking it's a bit steeper. What's e squared on 3, girls? Someone work out e squared on 3. So, when x is 0, we get a third. When x is 1, we get e on 3. When x is 2, we get e squared on 3. Look, that's... Can someone work that out? E squared. So it's about 2.5. Just to give you an idea roughly of where to put it, you can put 2, e squared on 3. That other one is e on 3. Okay, so it's been compressed by a factor of 3 from the x-axis. So y equals e to the x has been compressed. Can you do the last one, please? By a factor of 3. From the x-axis. The next one, what is it? Isn't it just what? Isn't it just that top graph shifted 1 unit to the left? So you know what the easiest thing would be, just to take each of the x values and move them across by 1. Instead of writing 3 here, sorry about the liquid paper, I'd write that as 0, 3. It's really going to help you write the new point. Instead of writing it as the y-intercept 3, write it as 0, 3, because it's going to help you with your translation. So your 0, 3 gets moved 1 unit to the left, and your 1, 3e gets moved 1 unit to the left. Do you already know what the equation is? I mean, so what are your points? What's your y-intercept now? I mean, look, you can just substitute in here. When x is 0, what do you get? You get 3e, but we already knew from here that it gets moved 1 unit to the left, so I know it's 0, 3e, and I know that this point is 1 unit to the left, negative 1, 3. So that's the other thing to do. Okay, so it's been stretched by a factor of 3 and shifted 1 unit to the left. Okay, all good, keep going. Do the next ones. So you've got the absolute value ones next. So it's stretched by a factor of 3. So that's what happened. Y equals e to the x was stretched by a factor of 3 and shifted 1 unit left. All right, keep going. Off you go. Y equals absolute value of x y equals 2 times the absolute value of x. Same things. Y equals half absolute value of x. Y equals 2 times the absolute value of x minus 3. Quick sketch. You should be able to do them really quickly. Just do 3 points or 2 points. 2 points is enough. You just tell me about this one. Isn't it just that one? Stretched by a factor of 2. So give me a point. So the V stays in the same spot, the vertex. And what's just this point here? Instead of 1, 1, it's 1, 2. That'll do. That's enough. And here I've got 0, 0. So that's good enough. A sketch, 2 points is enough. Okay? If you want, you could put this one, which is negative 1, 2. Stretched by a factor of 2. Do the other ones, please, quickly. You would have 1, a half. Or another point would be 2, 1, for example. 1, a half and 2, 1. This has been compressed. So y equals absolute value of x is compressed by a factor of 2 from the x-axis. And the other first one was stretched by a factor of 2 from the x-axis. And what's this last one? Steeper and shifted. 3 to the right. So put your 3 there. It's steeper. I don't know how. And you just need, I'd be doing this y-intercept, x-intercept would be enough for that. Maybe another point like this one, 1 something, just to show. 1. So I want that point, 1 something. It is very good. 4, thank you. 4, 2, good. And this one, 6. There you go. So that was stretched by a factor of 2 and shifted. 3. Stretched by a factor of 2 from the x-axis and shifted. 3 to the right. Stretched by a factor of 2 from x-axis and shifted 3 units right. All right, first graph here, a cubic. But to be able to draw it, you need to factorize. X bracket 1 minus x squared. Keep factorizing. X bracket and bracket. Difference of 2 squares. 1 is 1 squared. So I've got 1 squared minus x squared, which is a squared minus b squared, which is 1 minus x, 1 plus x. The way it's written. A squared minus b squared is a minus b, bracket a plus b. Both in brackets. Okay, this is a cubic. Does anyone know? So where does it cut? So at x is 0, at x is 1, and at x is negative 1. Do you think, is the x cubed term positive or negative? Look at the original graph. Negative. It actually goes backwards like this. Now, most of you, if you don't know that, because cubics will go, cubics with extra pieces tend to go like this, right? If you can factorize it and you get 3 roots, I've got a root at 0, root at 1, root at negative 1. But if we're not sure about that, how would we just double check? By substituting x is negative 2 into this. Or into that, it doesn't matter. When x is negative 2, what do you get here? A positive or a negative? Negative. So when x is negative 2, I get y equals negative times, what about when x is negative 2 here? 1 minus negative 2 is a positive times, when x is negative 2, I get a negative. Do you see what I'm doing? So you get a positive. It is up there. Okay? If you have to, you could work it out too. Negative 2, comma, what's that? Negative 2 minus, negative 2, 10, I think. Negative 2, no, it's not. It's positive 6. Because it's negative 2 minus negative 8 is negative 2 plus 8 is 6. So it's the point negative 2, 6. Okay, we're doing this one now. Y equals 2 bracket x minus x cubed. So I'm going to factorize it again. 2 bracket, no, 2, take out the x, 1 minus x squared. Are we okay with that? Which is 2x 1 minus x, 1 plus x. Compare this with that. Isn't just the second equation twice the stretched by a factor of 2? So all the intercepts are the same. It's just that it's going to be taller. So it was really good that we have this point here, negative 2, 6. What's that point now going to be? Negative 2 what? Negative 2, 12. So with this next graph, the intercepts are still the same. I've got intercepts at 0, negative 1 and positive 1. And it'll just be steeper. So I'd be getting these other bits. You know how, look, what you might want to do, if you want, these points will be different as well. So for example, this point here on the first graph is a half. Maybe it's a half. Actually, I can't be sure of that, so I'm not going to put that in. You can't tell that it's going to happen exactly halfway unless I do something called differentiate and find the stationary points, which we haven't learned how to do. So I'm not going to put what the coordinates of this maximum turning point and minimum turning point are, because I don't know what they are. It would only be exactly at a half if it had symmetry. But what I can indicate is that this point, instead of being negative 2, 6, it will be negative 2, 12. Okay? And this point down here at, say, 2 something, this is more than likely 2, 6. 2, negative 6. So on this graph, the corresponding point would be 2, negative 12. Now, look, I know this graph should have been a lot steeper, but I'm indicating the points here on the scale. And that's the only way you can tell the difference. If I was to sketch it on the other graph, it's probably best to sketch them on the same graph. I would have just done this a lot steeper, come down here, come up there, and go steeper there, which you can't see. So the original graph would have looked like this on that graph. Look. That would have been the original one. Now, so this is steeper. The pink one is steeper. Okay? What about this one? I know that looks horrible, but it's pretty much, and I'm missing an X. No, I'm not. I've got it all. I know that looks terrible, but compare that and that. Compare that and this. What's the difference? What happened to the X here? It became a... Look, the 2's the same. X is now a X plus 1. And this X, it's just shifted 1 unit to the left. So it's this pink graph shifted 1 unit to the left. If I take out the... If I factorize out the X plus 1, I get this. Actually, the cubed is not out there, it's here. Mistake, the cubed is in there. Fix the 3. Look, I can still play around with it, but you're meant to just compare that with this. It looks like the x's have been shifted by 1 unit to the left. But if I expand, if I take out x plus 1 as a common factor, I get 1 minus x plus 1 squared. I can now, I know this is a bit tricky, I can now do this as a minus b, a plus b if I want. You will still get similar intercepts. I'll do that. A minus b, a plus b. I'll just show you how it is translated. To the left, we've got 2 bracket x plus 1. What's 1 minus x? That would be minus 1. Isn't that just x? And 1 plus x plus 1, that's x plus 2. So if I do that and factorize and re-expand this, because this is 1 minus x plus 1 squared, you can treat it as 1 squared minus x plus 1 squared. It's a squared minus b squared. A minus b, a plus b. If you simplify that and this, you get this. Where are my intercepts at now? Aren't they at negative 1, 0 and negative 2? So negative 2, negative 1 and 0. It did just get shifted 1 unit to the left. Instead of negative 1, 0, 1, they're now at negative 2, negative 1, 0. So it is just that graph shifted 1 unit to the left, as we thought. All right? So we just do that graph again. So instead of, you've got your intercepts at -2, -1 and 0, and it's still steep like the other one. I know that's drawn badly. So instead of -2, 12, what's this point? Negative what, 12? Anyone? -3, 12. And this one, instead of 2, -12, it's 1, -12. Okay? So this is y equals 2 bracket x minus x cubed shifted 1 unit to the left. Okay? I know that one's tricky. Just a few more questions here. So looking at y equals 2 to the power of x, which is an exponential function, and y equals 1/2 times 2 to the power of x. So just looking at a quick table of values, when x is 0, 2 to the power of 0 is 1. When x is 1, y is 2. And when x is 2, y is 4. So we've got 0, 1, 1, 2, and 2, 4. And also, say when x is -1, we get 2 to the power of -1, which is 1/2. So just over here, going down there, and remembering that the negative x-axis here is an asymptote. Okay, so this is y equals 2 to the power of x. Now looking at y equals 1/2 times 2 to the power of x. This could also be presented as 2 to the power of x divided by 2. So it is not going to be stretched in the from the x-axis or away from the x-axis. It's going to be compressed. So just looking at a quick table of values there for x and y. When x is, say, -1, so 2 to the -1 is 1/2, so 1/2 times 1/2 is 1/4. When x is 0, 2 to the power of 0 is 1. 1 times 1/2 is 1/2. When x is 1, 2 to the power of 1 is 2. 2 divided by 2 is 1. So before we had the 0.12, now we've got the 0.11. And when x is 2, 2 to the power of 2 is 4. 1/2 of 4 is 2. So we've got the 0.11. We've got the 0.22. Okay, and 1/2 is where it cuts at the is the y-intercept. So the y-intercept is 0, 1/2. This is the 0.11. So before it was 1, 2. It's been compressed by a factor of 2. And this point here is 2, 2 instead of 2, 4. So the graph y equals 2 to the power of x has been compressed. By a factor of 2 from the x-axis. Okay, so it's compressed downwards. Okay, now just looking at these last two, we've got y equals log to the base 2 of x and y equals 2 times log to the base 2 of x. Just some suitable values to substitute. When x, so just over here, and y. Now, when x is 1, so we know that 0 is undefined, because even if we did change of base, you can't find the log of 0, so that's undefined. ln, so log to the base 2 of 1, so remember log to the base 2 of 1, that is log to the base 10, or log to the base e of 1, over log to the base 10 of 2, so I'll just do log to the base 10. But we know that log of 1 is 0. So 0 over 2 is 0. Okay, and now 2 is a really good value to choose. So log to the base 2 of 2 is 1. And actually 4 is a really good value to choose, because log to the base 2 of 4 is, we say 2 to the power of what is 4, and it's 2. Okay, so just remembering that from prelim. So log to the base 2 of 4, we say 2 to the power of what is 4, it's 2 squared is 4. So plotting that, we've got 0, that's undefined, 1, 0, 2, 1, sorry, 2, 1, and So I'm just going to go 1, 2, 3, 4, and then we've got 4, 2. So 4, 2 is there. And we know that the log curve, that the line y equals 0 is a vertical asymptote. So this is y equals log to the base 2 of x. Now to sketch the graph y equals 2 times log to the base 2 of x, this has been stretched vertically. So this is y equals log to the base 2 of x stretched or dilated vertically, stretched by a factor of 2 from the x-axis. So you don't need to do a table of values, okay? So when so we've got when x is 1, okay, so I'll just make this a bit bigger so that you can see, sorry. So we've got before, when x is 0, we know we've got undefined. When x is 1, we got 0 before, and 2 times 0 is 0. When x is 2, before we had the 0.21, because this has been stretched vertically, we will now have the 0.22. So we've got the 0.10 and we've got the 0.22 because we know it's been stretched vertically, but you can check. So when x is 2, log to the base 2 of 2 is 1, 2 times 1 is 2, and when x is 4, before we had 4, 2, now we will get 4, 4. Because it's been stretched or dilated by a factor of 2 from the x-axis. The shape will be, the shape is still the same, but it's just a lot steeper. Okay, so yeah, okay, so notice this is a lot flatter. This is steeper. This is the 0.44. Please don't draw a straight line between there and there. You've got to keep that shape. That logarithmic curve looks like this. Okay, so you need to keep that shape. It is not a straight line graph, so just make it a bit more rounded there. Okay, so it's passing through 2, 2 and 4, 4. Okay, so this is y equals log to the base 2 of x stretched or dilated by a factor of 2 from the x-axis. Okay.